Hey everyone, and welcome. Today, we're going to dive into something really cool. How artificial intelligence is basically becoming a guardian angel for all the machines we count on every single day.
Okay, just think about this for a second. What if we had a kind of crystal ball for our most critical technology? A way to see a disaster coming and stop it dead in its tracks.
Because, let's be real, the stakes can be incredibly high. We're talking about the engines on a plane or the power grid that keeps our entire world running. In those situations, waiting for something to go wrong, that's just not an option.
For the longest time, our whole approach has been, well, reactive. Something breaks, we rush to fix it. But that whole break-fix cycle, it's not just costly and inefficient, it can be downright dangerous.
But what if there was a smarter way? This is where our hero, AI, steps onto the stage. It's giving us that digital crystal ball through an amazing approach called predictive maintenance. So what exactly is predictive maintenance? Well, it's pretty much what it sounds like. Instead of just waiting for a machine to break, we use AI to listen to its heartbeat 24/7. It chews through mountains of data, vibrations, temperatures, you name it, to find those tiny, almost invisible clues that scream, hey, something's about to go wrong here.
So how does the magic happen? It's actually a pretty logical four-step dance. First, you've got to collect tons of data from the machine as it's running. Then, you use that data to train an AI model, teaching it exactly what normal looks like. After that, the AI just watches, looking for any little hiccup, any deviation from that normal, what the pros call an anomaly. And finally, the prediction. Based on those little warning signs, it can forecast a failure and tell us, you need to fix this long before it actually breaks.
All right, let's get into some really cool stuff. How this is already being used to protect the heavy-duty machines that are the backbone of our world. Let's talk about the CFM56-7B jet engine. This thing powers a huge number of the planes you and I fly on. The need to predict something like metal fatigue here is, well, it's absolutely massive.
Now this is where it gets seriously clever. They're not just throwing raw data at an AI and hoping for the best. Nope, they're building what's called a physics-informed model. That means they're combining the incredible pattern spotting ability of AI with hard and fast scientific laws. In this case, something called Paris Law, which is basically the math behind how cracks grow. The result? A way smarter and more accurate prediction.
And this isn't just for airplanes. The exact same idea is being used all over the place. We're talking about the bearings in giant factory machines, the frames of powerful demolition robots, the pumps working deep underground to get oil, and even the steel beams holding up the buildings we live and work in.
Okay, so we've covered the big, heavy metal. But what about the electronics that run pretty much everything else? From huge power grids down to the tiny little chips in our phones, these systems are just as important.
And the change in thinking here is just as big. The old way was, well, you wait for something to fry, and then you panic and deal with the mess. The AI way? It's about constantly analyzing all the electronic signals in real time to spot a problem before it ever has a chance to cause an outage.
Here's a perfect example. The insulators in our power grid. These things are absolutely vital for stopping blackouts. But they can fail, and traditionally, you'd have no idea a problem was brewing until suddenly the lights go out.
So researchers put a few different AI models to the test. They analyzed these tiny, faint currents coming from the insulators, and what they found was pretty amazing. Regular AI models did okay, but one type, a recurrent neural network, or RNN, was the clear winner. And here's why. RNNs have a kind of memory. They don't just see a snapshot in time, they see patterns developing over time. That makes them perfect for catching the slow, quiet decay that leads to a big, sudden failure.
And this is happening all over the electronic world. It's making all those smart home gadgets more reliable, it's helping build better computer chips, it's keeping critical mapping and GPS, that's GIS, equipment online, and yeah, it's preventing the hardware in our computers from dying on us right when we need them the most.
So, when you step back and look at the big picture, it's obvious we're not just talking about some small upgrade. This is a total game changer. It's a revolution in how we manage, well, everything.
If there's one thing to take away from all this, it's this single massive shift in thinking. We're moving away from a world where we're always reacting to problems, to a world where we get ahead of them. We're going from fixing what's broken to preventing it from ever breaking in the first place. And the impact of that is just huge. It means safer planes, a power grid you can always count on, less downtime, more productivity. Simply put, it means a world that is safer, more efficient, and just plain more reliable.
Which leaves us with one last really fascinating question to think about. If AI can act as a guardian for all of our technology, if it can see these failures coming from a mile away, what else can it see coming?